Hello guys, welcome to our YouTube channel. We are still looking on calculus, and under calculus we're going to talk about logarithmic differentiation, and we all know that you are now aware about logarithmic differentiation. So been given this example which says find the derivative of y 2x minus 5 raised to the power 4 divided by 3x plus 1 raised to the power 3 using the logarithmic differentiation. So I wanted to attempt everything, not until I realized that we have to solve this together. So I started by rewriting the same function. So nothing has changed. I've just gotten this and brought it here. Then therefore what you're supposed to do, you have to introduce natural log both sides, and it's going to multiply y, and this side is going to multiply everything here. So therefore what we're supposed to do next is we have to change this and write it into this log. It should appear into both sides. So here we are having a fraction, and the fraction will change, and when the fraction changes it's going to be a negative. So in that process, what I mean is, let me demonstrate it. So it's 1y is equals to ln y is equal to natural log of 2x minus 5 raised to the power 4. So minus, so when it changes it's going to be, instead of division here there's a division, it's going to be a negative. So ln, remember this ln is applied to this one and also that one. So we're going to have 3x plus 1 raised to the power 3. So therefore what we're supposed to do is we take this power to this side. So remember to take this power to this side and this power to the other side. So I'm going to have ln y, which is equal to 4 ln 2x minus 5 minus 3 ln 3x plus 1. So reaching at this stage, what we are supposed to do is, I would love you guys to know that there's this formula. Let me write it here. dy dx is equals to the derivative of u over u. So which simply means is that you have to find the derivative of u, and then you divide it with the original of that equation or function. So in our case here, we know that our u, what is our u? It's 2x minus 5, and then our u prime is which means the derivative of u is, what's the derivative of 2x minus 5? It simply means it's 2. And then what we are going to do, what we've done to this side must also be done to the other side. So without wasting much of your time, what we are going to do, this one is going to be changed or we are going to use the implicit. So this one, when it's going to be changed, it's going to be, remember, implicit, it's the way it's done, it's the derivative of this multiplied by its derivative. So we're going to have y squared, y derivative, the derivative of y over y, which is equal to what is the derivative of this. So this one will multiply the derivative of what is in the bracket. So we are going to have 4 multiplied by, what is the derivative here? It's 2, remember this part. So it's 2 over the original equation, which is 2x minus 5. Same to the other side. We are going to have 3 multiplied by the derivative of what is inside. So we have 3 over 3x plus 1. So this is what we have. Then allow me to go back and explain a little bit on this. So for instance, when we're going to use this formula, let's talk about implicit. We said implicit is the derivative of, let's take for instance, being given x, or let me just keep y squared, not x. So you have y squared, and then they say that find the derivative of y squared using implicit. So what they mean is, you have the derivative of y, the derivative of y times its derivative. So this one is going to be 2y times dy dx, or it's going to be 2y multiplied by y prime. It's one and the same. So this is the same thing which has happened here. So to demonstrate on how we've arrived y prime over y, it's when we use our formula here. So we have ln y. So this one, since we are using implicit, it's going to be 1 over y divided times its derivative, which is y prime. So this times that one, we're going to have y prime over y. So that's how we have arrived here. So to continue with our problem, we are going to say the derivative of y over y, then we multiply this one times this one. It's 8 over 2x minus 5. Allow me to put this in brackets, minus this time is that one. It's 9 over 3x plus 1. So we've reached at this stage, and at this stage we all know that what we are supposed to do is we are going to subtract this, and subtracting this kind of a problem, we have to come up with a common denominator, and a common denominator of this, it's the both of these equations. So 2x minus 5 over 3x plus 1. So what we're going to do is this one into this, so which simply means this and this will cancel, and we're going to remain this side, we're going to remain with this times 8. So we're going to have 8 3x plus 1 minus, so same applies to the other side, this into all this simply means this and this will cancel, then we're remaining with this guy. So we're going to have negative 9 multiplied by 2x minus 5, and then fast forward, we're going to remember here we are moving with this guy, owner of the village. So y prime raised to the divided by y. So fast forward, we're going to expand this. So 8 times 3, we know that it's 24. 8 times 1 times 8 times 1, it's positive 8, minus it is negative 9 times 2, it's negative, so it's negative 18x. There's an x there. So what we're going to do next is negative 9 times negative 5, it's positive 45, divided by, bottom here we are not going to expand. 2x minus 5, 3x plus 1. So reaching at this stage, we are going to group the like terms and do what we are supposed to do. So y prime over y is going to be, so here we know that we can add just a little bit. I've forgotten x here, supposed to be x. So we are going to add this and this, and then subtract this and this. Remember, there's this one, there's a negative. So for the sake of those who are going to be confused, so we have 24x minus 18x plus 45 plus 8. I haven't changed anything, I've just grouped the like terms. So we have 2x minus 5, then 3x plus 1. So these are the common denominators. So when we're going to subtract 24x minus 18x, so we're going to remain with 6x plus, here it's 53. We've added 45 plus 8 over 2x minus 5, then 3x plus 1. So reaching at this stage, we are going to make y prime the subject of the formula. So what we are going to do, we are going to cross multiplication. As we are crossing multiplication, this one y prime, it won't multiply this one. Instead, we are going to consider the denominator side and we multiply with the numerator of the other side. So what I mean is y prime is going to be equal to y multiplied by 6x plus 53 all over 2x minus 5, 3x plus 1. So since we have this now, so what we're going to do is we have to go back to our question and get where there is y, we're going to get to replace it with the original function that we were given. So guys, our original function is this. So where there is y, we are going to put this function, the whole of it. So let's do it. So y prime is going to be equal to, remember we have our equation there, it's there. I hope you can see clearly. So we have 2x minus 5 minus 5 raised to the power 4 over 3x plus 1 raised to the power 3, and then multiplied by this equation here, this function. So we have 6x plus 53. Let me to put it in bracket. So I've got 2x minus 5, then 3x plus 1. I haven't changed anything. The only change which has occurred here, it's here. So I've gotten this equation because they're saying that y is equal to this. So where there is y, I have to replace by this function. So that's why you have seen I've replaced it here, in case you might be wondering that what is happening or where we've gotten this from. So what we're going to do here is we know this and this are the same, but the only difference is the power. So this equation has got a power here which is 1. It's invisible, but we all know that even this side there's 1, there's 1, there's 1, despite this one has been shown. So what we are going to do is we are going to divide this into this. So this cancels this into this. We're going to have y prime is equals to 2x minus 5 raised to the power 3. So this one can go into this 3 times. What I mean is that when we subtract, for instance, you have so you have maybe you have 2x plus 1 open brackets, and then 2x minus 1 over 2x plus 1. So what is going to happen is this and this will cancel, so you're going to remain with this one. So let's take for instance if you had maybe raised to the power 2, so which simply means this and this will go, and then you're going to remain with that guy. So this is the same thing which has happened here. So this will subtract 1 of this from this. So we're going to have 2x minus 5 raised to the power 3 over 3x plus 1 raised to the power 3 multiplied by 6x plus 53 all over. So here we are remaining with 3x plus 1. We are remaining with this guy. So what we're going to do here is y prime is equals to, so we're going to have 2x minus 5 raised to the power 3 multiplied by 6x plus 53 close bracket. So here we have what we're going to do. Okay, what we're going to do here is when we have the same denominator, what we're going to do is the powers must add. So what we're going to do is we're going to get one of this, so 3x plus 1. So when we add 3, remember here there's a 1 which is invisible, so we're going to add 1 plus 3, of which is going to be a 4, and this marks our final answer. So the most interesting part about logarithmic differentiation is about following the rule of logarithm. So if you are very behind, I would encourage you to go back into our channel or visit our channel, and then you go on the video which talks about logarithm, and you are going to get the rules of logarithm. But otherwise, the most interesting part is following the rules and the procedures on how we are supposed to deal with it. We are supposed to differentiate with the logarithm. Thank you very much for your time, and don't forget to subscribe to our YouTube channel, and kindly do us a favor by sharing our video. Thank you. See you another time.